I don't go on a balcony. I once was kidnapped by aliens. Bullshit. There are no aliens. Let me see. I cannot see any aliens. Come here, it's perfectly safe. Damn! I knew I was right! When your aliens are back, we see this hilarious. There are no aliens here. Where are your aliens? Here? No, I cannot see any aliens really. Hi guys, how's it going? I recently was asked where someone can find the differences between Java generations. For example, the language changes between Java 7 and Java 15. This is not so easy to find when you really want to get an exact answer, and you have to read a lot of diffs. But for those who really like to get the ultimate answer, here's how to proceed. OpenJDK is a definitive and authoritative source to find an answer, so let's go there. First of all, you need to understand that there is a separate document for the big picture, the language, the API and the JVM of each Java generation. In this video we will concentrate on the Java language and ignore the changes in the JVM and the API. Starting from each generation's root page, we navigate to the language specs differences. And here we have the language spec, and this is the differences file. This one is for Java 15 and there is one such file for each generation of Java. This document contains the changes since the predecessing version in colored text. So now just stop reading when you find colors. And this might be a lot. So stop here. So you see the additions in blue or in red. As the document is hundreds of pages, you might wonder if there is an easier way. Sure there is. Nevertheless, it's a bit imprecise. Thanks to this great blog entry from Andre, we can get it in list form. The drawback is it is starting with Java 9 and not earlier, and if he ceases to update it, we are stuck. But why should you bother at all with language changes? Isn't this just about details? Did the language change so much? Well, yes, it did. Java 15 is substantially different to Java 7. In Java 7, you were used to write if, else and for to branch and loop, which are imperative core structures. Typically you wrote them top down, and the compiler and virtual machine had to deal with lots of custom code, the code you wrote. Mostly interpreted custom code at runtime, hence rather slow and seldomly called. In Java 8, you could use optional and streams instead, typically write them left to right, which changes the direction clearly. Already compiled system classes and reused so often that they are natively compiled guaranteed, hence potentially faster depending on the use case. Yes, this is not a language change but an API addition, but as it reduces the need for if, else and for, it feels like a language idiom. Also, since Java 8, there are lambda expressions, functional interfaces and method references, allowing to spare lots of custom code, or making custom code much shorter and, when used appropriately, much concise and such better to read. Passing around method references makes interface design completely different. Now we can clearly express to forward and eventually invoke a complete unknown method as long as the type signature is matching. No forced implements or extends needed anymore. Well, you might ask, what's so bad about implements and extends? Well, the class author has to know the interface or superclass at time of writing the class. This is like if you would need to know where you want to drive with your car in the future right at the time of its design. So you cannot drive on roads built later. Weird, isn't it? Method references allow the decision to pass a method based on its existing type signature long after the invoked class was published. Also, it cleans the domain design, as typically you want to extend from another domain class, not from a technically needed abstract parent. When it comes to complex designs, it is a good thing that interfaces are allowed to provide default implementations, so we can extend them later without breaking backwards compatibility. And having static methods in interfaces allows a designer to provide helpful utility code without a need to extend from an abstract implementation. This spares a lot of actually useless abstract classes that were so typical in old school Java. No way to write, compile and class load them. In Java 9, the idea of interfaces instead of abstract classes was extended by private interface methods, so we could even implement the default and static interface methods more clean and more reusable. And more reusable always goes along with more speed in Java, as you know. Speaking of Java 9, most people think about modules, but least of them are using them. I wonder why. As you start using them, you gain the ability to declare friendship among classes over package borders without publishing your code to the whole world at the same time. For libraries, this is actually inevitable, as you can see a lot of synthetic package names like .impl in the name in many existing libraries. Yes, this is hard work and your dependencies are not modularized, I know. So please, library authors, modularize your existing libraries now. Jakarta EE, by the way, will provide all its libraries in a modularized fashion quite soon. Maybe this will be a trigger for you. Java 10 brought us the keyword var, so we can stop explicitly writing down the type of local variables, and with that get rid of many import declarations. As the type is inferred, not forgotten, the code is safe as before and your IDE still knows what to propose you when you type a dot. But the code is much easier to read now, as the short lowercase word var is rather invisible and all names are on the same line. Also, it reduces the length of the code lines, possibly considerably, depending on the replaced or even repeated class name. This looks very pleasing and after a short time you will love that code layout. For me, this is one of my favorites in Java 10. And since Java 11 you could use var also within lambdas to align with its syntax, I personally think this is counterproductive, but maybe you like it. Since Java 12 you can use switch as an expression, and since 14 this is production ready. This is something I personally was used from some SQL dialects, and it is very handy as again, the reader's flow now goes from left to right instead from top to bottom, which allows us to finally write Java in a rather fluent sentences style, which contain an idea completely instead of spreading it over multiple lines. This helps understanding the semantic idea behind your code really, and it introduces the word yield. Unfortunately, I would love the word return more, as it basically does the same and we're used to write fail fast return in old school switch anyways. In future, the idiom of Java will change more, as since Java 13 and 14 some interesting keywords are in preview. Starting with Java 15, text blocks will be ready for production, and this is something I really missed a lot in the past. In the past years I had to write a lot of unit tests where I had to compare multi-line strings, expected output with actual input. Text blocks will definitively make that code look better by far, as I can spare all those double quotes in every line. Unfortunately, 15 will contain only a second preview of records, but it is worth looking into it though. The record keyword really helps to get rid of huge amounts of useless getter, setter, hash code and equals code lines we all had to write all the time, again and again for a long time. Possibly doing it wrong, or just maintaining a static text stencil provided by your IDE just for nothing. That all gets replaced by a single line. How great is that? I know hundreds of code files I literally can throw away now. This is pretty cool. And also I expect that compiling my huge projects with thousands of source code files full of this static code will speed up also, as those files won't exist anymore. Okay, I know this was quite a long monologue and you actually demand to see some real code. Also, this was neither comprehensive. I'm sorry for both. If I forgot a language change, please write them down in the comment section. But I thought it might be a good idea to first give you a core idea of the big picture of modern Java. This ain't your daddy's Java anymore. Use all these items together, show it to coworker, and you will see what I mean. The language has changed a lot, and the style we write and read is now massively changed thanks to the new idioms we apply in recent versions. And in future generations it might change further. Noteworthy idiom changes come from fibers of Project Loom and value classes of Project Valhalla. I really look forward to both, and I hope they will be here in Java 17 or even in 16 as a preview already. Also, sealed classes, that is like French in C++, will hopefully be production ready then. You can preview them in 15 already. This will make another real difference to your existing codebase, and I do promise in the next episode you will see some real source code again. Also, I'm planning some episodes where eventually the new keywords will be used gradually. So come back often, or even better, subscribe to my channel to see modern Java in action. I hope you got an idea of modern Java now and you like this video so much that you give it a thumbs up. Stay safe and party on. Nochmal komplett. Third code log change thanks to new idiots. Idiots. Nochmal. Broad.